Hello and welcome to the second video of the FP2 chapter, Inequalities. Start a question on the screen. I will come back to this same question at the end of the video, solving it using the method we're looking at in this video, but here solve using algebra to review the work we did in the last video. Pause the video now if you've got time, give this a go. What we're going to do is multiply both sides by the denominator of that fraction squared. On the left-hand side, one of those cancels. On the right-hand side, we have the squared there. Then we said rather than expanding that, it's easier because we know they're going to have a common factor to move it and factorize first, and then expand what you get left. In this case, I can factorize that, which leaves a 2 in the first bit, and a minus x squared minus 1 here in the second bit. So that becomes 2 minus x squared plus 1, we get 3 minus x squared. Then I need the critical values. Here we've got x is plus or minus the square root of 1, that's 1. And here we get x is equal to plus or minus the square root of 3. Now to see which intervals this holds true for, I can either sketch the graph or I can do point testing. I prefer to sketch the graph because this is a quartic equation, and I know generally speaking that looks something like this, but in this case if I expand this out it would be a negative x power 4, so actually in this case it'll look more like this. So if I want to sketch this quickly on the side, I know the key points where it intersects the axis are minus root 3, minus 1, 1, root 3. If I wanted to, I could expand this out quickly to find the constant term where it intersects the y-axis, but because I know it has this general shape, I know it must start on the negative side because this will keep going down forever, so it must start on the negative side of the x-axis, which means it crosses like this. It doesn't really matter where it crosses the y-axis. For my solution intervals, I know now that where this thing is greater than 0 is in this interval, from minus root 3 to minus 1, and in this interval here, 1 to root 3. And these are the two solution intervals, and hopefully we will find the same solution intervals later in the video when we solve this using the method of sketching a graph. Now I'll come back to this later as well because it's good to emphasize, but I know I did sketch a graph here. That's not the main method I used though. The main method I used was solving using algebra. Sketching the graph was just to solve this little bit here at the very end, and I didn't need to sketch a graph. I could have done point testing. So this is using algebra, and here we're going to look at the main method being sketching a graph. If you can sketch the graph of the two sides of the inequality, you can solve the inequality just by looking at the intervals where one curve is above the other. To identify the intervals, however, you will need to know the points of intersection of the two graphs, and you'll find that by solving the equation of the two expressions. So again, there is going to be a bit of algebra in this method, but the main method is going to be sketching the graphs. So what we're going to do here is try to solve this inequality by first sketching this graph, and then just comparing where is this graph less than, i.e. further down the y-axis than this graph. So the playoff between the two methods here is that sketching the graph in this case is going to be quite a bit harder because sketching something like this is a bit more involved than sketching a quartic equation. However, the algebra involved when we get to doing that will be a lot easier because we'll be solving an equation, not an inequality. Let's put that to one side for now and get on with the question. So I need to sketch these two. I'm going to sketch the easy one first. So bring up my pair of axes here. And the easy one, y equals 4 minus x, just looks like this. So this is a 4, and this is a 4. The harder one, depending on your graph sketching skills, I think this is harder, is this one here. But there are certain things we can do to make this a little bit easier. We can consider points of intersection with the axes. Obvious one to start with, what happens when x is 0? If x is 0 here, 0 here, 0 plus 1 is a 1, 0 divided by 1 is a 0. So when x is 0, y is 0 as well. That tells me it passes through this point in the center. Another quick thing to do is to check when the denominator of the fraction would be 0, because we can't have that. The denominator here would be 0 when x is equal to minus 1/3. So at this point there must be an asymptote, because the graph can't go on to that point. So let me put that in green. My scale is not quite reasonable, but that's okay. Here. So the blue graph that I'm going to sketch for this function does not cross this line, but it does get very close to this line. If I go just a little bit to one side of this value, so I go very close to minus 1/3, say minus 0.3, just on this side of that, put that into my equation, I'll find a really big negative number. And that tells me that this is coming from down here to cross this point here. And then if I make this really, really big, put in a really big x, say 1,000, then 7,000 divided by 3,001, you'll find that that gets closer and closer to 7/3. What I'm doing there more formally is saying when x tends to infinity, gets really, really big, then y tends to 7x/3x, because the plus 1, when this number here is really big, the plus 1 is making very little difference. It is making a difference, I can't say that it's equal, but it's such a small difference that it's getting very, very close to 7x/3x, which of course would become 7/3. So the bigger x gets, the closer y comes to 7/3. So that's another asymptote on the y-axis this time. And that gives me the shape of my graph. I know it starts very low down here, I know it must go through 0, 0, I know it gets closer and closer to this value, the bigger x gets. So it looks something like, if I can draw it, that. And with this general sort of graph, a reciprocal, I know I get a very similar shape over here. And you could test that out if you weren't happy with me just making that assumption. What happens if x is just a little bit lower down than minus 1/3, say minus 0.35 or something, you'll find a really positive number, and as x gets bigger and bigger on the negative, you'll get closer and closer to this 7/3 again, but it'll be slightly bigger than 7/3 rather than slightly smaller than 7/3. And you can check all of that yourself on your calculator if you like. What do I do with this now? I'm asking, when is the blue graph less than or lower down than the red graph? Well, the blue graph starts lower down if I go from left to right, all the way up to here. And then the blue graph gets higher up or greater than. So I want to know, what is this point here? Because everything less than that x value is going to be true for this statement. But between here and the asymptote, the blue graph is greater than, not less than, the red graph. And then after the asymptote, it jumps down here, and the blue graph is less than again all the way up to this point. So from minus 1/3 all the way up to whatever this point here is, so I need to know what is that, then this thing is true again. And anything bigger than this value, the blue graph is greater than the red graph, so it's not true anymore. So I want this value less than that and between minus 1/3 to this value here. And this is where we get back to our algebra. We do need a bit of algebra, but it's much easier because we just need to solve the equation to find the points of intersection. We already know the intervals, we just need the numbers. So we do 7x/3x plus 1 has to equal 4 minus x. We don't need to worry about flipping signs or squaring anything. We just go ahead and do this as normal. Then we expand this out. We're going to get minus 3x squared. 12 minus 1 is 11x. plus 4. I like all of mine on the left with the x squared positive, so that will be minus 4x minus 4. And I think that will factorize. We'll get a 2 and a 2, and that'll have to be a minus there and a plus there. So our two answers for the critical values, the points of intersection, we get x is equal to 2 and x is equal to minus 2 over 3. And you can see now from the graph which one of these is which, because the minus must be here. So anything less than minus 2 over 3 is correct for this inequality. So that is the first solution interval. And then anything between minus 1 over 3 and the other value, which is obviously the 2, is also true. So minus 1 over 3 from the asymptote to where they cross again at the value 2 will also make this statement true. So we have finished. Here we have our two solution intervals. So I know I've said this a couple of times already, but you've got to be careful you know which method you're being asked to use in terms of an exam. And the two methods are solving using algebra. That means you'll be solving an inequality by squaring anything in the denominator of a fraction. And you might use a sketch, or you might use point testing, but you might still use a sketch as part of that at the end of that method to identify the intervals. But the main method is solving the inequality using algebra. Contrasting with that is what we just did, solve by sketching. You must sketch the graphs first. Then as part of that you will do a bit of algebra, but it won't be solving an inequality. You'll be solving the equation just to find the points of intersection that you've already seen on your graphs. Now to highlight how different the graphs can be in these two situations, I'm going to go back to that starter question and solve it by sketching. We solved it using algebra at the very beginning of the video, and that gave us a sort of a wiggly M-shape quartic equation. I'm going to sketch the two graphs in the inequality now and show you just how different that looks. So we need to sketch the graph of this and the graph of this, which obviously is much easier, and then see where is this graph greater than this graph. So let's get the easy one done. Y is equal to 2. I'm going to put that here. And then we need to go through our graph sketching skills again. So let's think. This cannot be a 1, because otherwise the denominator would be 0. But it also cannot be a minus 1 for the same reason. So we've got two asymptotes straight away at 1 and minus 1. That's not all that useful just by itself. I don't know the shape of the graph yet. I need to keep going. So let's think of intersection points. When x is 0, what happens? So if we put x is 0 into here, we get minus 4. So when x is 0, y is minus 4. Okay, that's down here somewhere. That helps a little bit, but again, I can't draw the graph just yet. Don't have enough information. Now I need to start thinking what happens either side of the asymptotes. If I do it just a little bit bigger than 1 or just a little bit smaller than 1, is it an asymptote that goes up here or one that goes down here? The other thing that I could consider at this point is what happens when x gets really, really big in the positive direction and what happens when x gets really, really big in the negative direction. So I'll look at those two and then I'll go back to the asymptotes. So if you get a really, really big x here, this is going to get huge when you square it. The minus 1 is going to be negligible. So you get a really, really big number in the denominator. 4 divided by a huge number is going to be a tiny number. As this gets bigger, this is going to get smaller and smaller. So let's say when x tends to infinity, gets really, really big, y will tend to 0. It will never get to 0. Let me be clear on that. But it will get closer and closer to 0. And if x is a positive number, a really big positive number, this will be a really, really small positive number. So it's coming down towards 0 here. So I'm not going to do the calculation, but I strongly suspect if you use x is equal to something just bigger than 1, like 1.001, you'll end up with a really, really high positive number. So I'm going to put that bit of the graph in here. Now what happens if we do the same thing with the negative? If x is a really, really big negative number and I square it, I get a really, really big positive number. So I get the same result with a really big negative number. I'm going to get closer and closer to 0, and it's still going to be on the positive side. So this is going to be a bit of symmetry here. Now I don't know how curvy or how sort of box-like these bits are, but that doesn't really matter. I'm just looking at where it's going to cross this y equals 2 graph. Now what happens in the middle? This is a little bit harder because these bits haven't really helped me with that. I need to consider what happens just bigger than -1, maybe minus 0.9, and just less than 1, maybe 0.9. And if you put those two values on your calculator, you'll find this becomes really close to 1. You subtract a 1, it's a really small but negative answer, whether you start with a positive x or negative x. So 4 divided by a really small negative answer gives you a really big negative answer. So as you get closer to the two asymptotes here from the middle of the graph, it gets really, really negative. So I can now put that in because I know it must cross the axis at -4. It gets really negative here, really negative here. It crosses the axis, so it must do something like this. And there I have drawn my graph. Now I look at the points where they intersect because I need to know when is this greater than 2. It's greater than 2 from here to the asymptote. So I need to know what is this point. And it's greater than 2 from the asymptote to here. So again, I know the asymptotes already, but I need to know these 2 points to get this interval here and this interval here, which is where this inequality is true. Again, to do that, the algebra itself is quite straightforward. We're just solving when is that equal to 2. Bring the 2 down and the x squared minus 1 up. We get a 2 is equal to x squared minus 1. So x squared is equal to 3. X is equal to plus or minus root 3. So the intervals, if I put these in, this must be root 3 and minus root 3. The intervals then are minus root 3, x to minus 1, and 1 x to root 3, as we had in the starter question. And you can see that the graph is really very different from that m wiggle that we had at the beginning. This is much more involved to draw, but the algebra is much easier. Previously the algebra was more involved and the graph at the end was much easier, but they gave you the same solution intervals. And that's the whole point. You've got two different methods of doing the same thing. You need to be careful in an exam, however, which one it's asking you to do. If your graph drawing skills are not so great, as with any other skill in life, you need a bit more practice, and you can do that using the relevant exercise in the textbook. For the Edexcel one, it's exercise 1b. And maybe I'll see you in the next video, where we will apply this method to inequalities involving the modulus. Maybe I'll see you there.